it's changing. It's going to change increasingly in the future. What we're doing is obviously one very, very small piece of the puzzle that's Greenland. My role, as well as being a scientist, I feel, is to kind of share the wonder of these environments, tell people across the world about the wonderful landscapes that are there, the glorious environment and atmosphere.
Meet Dr. Neil Ross. He's a glacial geophysicist from Newcastle and one of very few who's journeyed to both of the Earth's icy polar regions. Here on remote and sparsely populated Greenland, he and fellow researchers are on a climate mission, this time to uncover how quickly changing conditions are melting two of Greenland's glaciers.
So we have an ice radar. It's a kind of 30-metre long bit of equipment which has a transmitter and a receiver, and the transmitter sends a radio wave into the ice, down to the bottom of the ice, and that radio wave bounces off things where there's a change, and we can measure that at the receiver when the energy comes back.
Is it an easy process getting these kind of measurements?
No, these measurements are extremely hard to get. The easiest way to get them is from aircraft, but what we've been doing over the last 2 weeks is actually being on the ground, roped together with crampons and pulling the radar manually up and down over the kind of undulating ice sheet. We've had to be really careful about where we walk because there's lots of crevasses in the ice sheet, so where the ice is actually fractured and broken, so there's some big holes in the ice, and also these huge vertical tunnels we've got to avoid.
With the data gathered using the ice radar, Dr. Ross and his fellow researchers can make cross-sections of the ice in the same way you might measure the distance from a plane to the ground.
What we're trying to do is contribute more and more knowledge about the processes that go on in the ice sheet, on top of the ice sheet and under the ice sheet, and we can use those to inform the computer models that are used to predict how the ice sheet behaves and how much it will contribute towards global sea level in the future.
Like its polar opposite Antarctica, Greenland's ice is vanishing at a rate that's alarming scientists the world over.
Greenland is currently losing over 300 gigatons of ice per year, which is a vast kind of amount of water that's being released. Over the next kind of 50 to 100 years, we're going to see global sea levels rising in the order, by the end of the century, by 60 centimetres. That doesn't seem like a very large amount, but locally that could be very significant. There might be higher sea level rises in some parts of the world than others. There might be coastal erosion, so people might lose their houses. There might be flooding of kind of low-lying areas across kind of the parts of Florida, for example, parts of the New York area. We've seen some very big hurricane events in the US in recent years, and if we're adding to global sea level as well, then the flooding from those hurricane events will be exacerbated and more significant in the future in combination with this rising sea level. The key message about Greenland is that it's changing, it's going to change increasingly in the future, it's going to contribute more to global sea level, and we all need to be doing something, reducing the amount of carbon that we're emitting into the atmosphere in terms of our day-to-day lives to help protect that.